I'm going to do a video to finish the notes for sections 2.3 and 2.4. So we started this, and we worked through several of the problems, so I won't rework those. But section 2.3 deals with set operations, and then section 2.4 is where we look at trying to analyze survey results like the water activities problem, and we work a little more with something called cardinality. Okay, so we did a lot of the problems from 2.3. I just skipped a couple. So if I remember correctly, we had done all the way through through 8, but I skipped this one so I could get into some of the problems dealing with Venn diagrams. Okay, so I wanted to start with question number 9. So on this one, we're working with the difference, the operation in the set operation involving the difference of two sets. Okay, so when you're doing that, the order really matters. So if it's A minus B, then you start with just the elements from section A, from set A, I mean. Okay, then think of that as take away set B. So take away any elements that you see here that are in set B. So you look at set B, and if there had been an A, you would take it away. You need to take away B because it's in set B. You need to take away the D. You need to take away the H, okay, because they're in set B. And then your answer to that question would be what you have left, which is just E, F, and G. Okay. All right, if it were A minus C, you start with set A. So that's the B, D, E, F, G, H. Then you look at set G. Let me do this one in green. Set C, I mean. Okay, so when we're trying to do A minus C, the difference of set A and set C. Set A was the first set, so we write that down here. And then we take away any elements from this set that we see in set C. So we would take away the B, the E, and the G, and then the answer would be the elements that are left from set A. Once we knock out the B, the E, and the G. So that would be your answer to that one. Now, on C, we have the complement of A that we're going to need, and on D, we need the complement of C. So let's go ahead and do those two things right here. So A's complement would be everything from the universal set except these, okay? And the universal set is all the letters from A to K. So I would need the A, the C, so I'm thinking A, B, C, D, E, F, G, H. I would need the I, the J, and the K. Okay, so I could have done that by crossing out the B, the D, the E, F, G, H, and then taking all the elements that were left. Okay. Now for the complement of C, I'm comparing set C with the universal set, and I know the complement would be everything in the universal set except B, E, and G. So it would be A, C, D, F, H, I, J, K. I like crossing out. I like doing what I did, crossing out the B, the E, and the G, so that I don't have to think so hard and I can just write down what the elements of the complement of C would be. Okay. Now, let's work on these two problems. So let's do this one. Okay, I'm running out of room, so I'm going to, well, let me see if I can just move that over. No, it's all clipped. Never mind. So I'm gonna be working on that right here. Let me bring that down. So C, I'm trying to do the complement of A, take away B. So I'm gonna work on I've already done the complement of A, so I'm gonna write that down first. Okay. Then what I need to do is remove from there, I need to take away the elements from B. So I'm looking at set B, and I'm going to take away the A, because it's in set B, and the I, because it's in set B, And that would leave me C, J, and K. So that would be my answer. Okay. And then for D, I start with set A. Okay. So D says A, take away the complement of C. So I'm going to start with set A. B, D, E, F, G, H. Okay. And then I need to take away elements in the complement of C. So I'm looking here at the complement of C. And I'm going to knock out a D. E is not in the complement of C. F, I'm going to knock out. G is not in the complement of C. H, I'm going to knock out. Okay? And so what I wind up with is a B, an E, and a G, which coincidentally is set C. That did not have to turn out that way, but it did. Okay. All right, now I don't think we finished 10. So I'm going to go ahead and do that one. So when you're doing this question, there's two sets involved. The universal set is all the elements under consideration, but then there's a set A and a set B. So let me label those circles. So our job here is to place these numbers. So the numbers we're trying to place are the numbers 1 through 8 into the correct spot. So before you get started, what you want to notice is that 6 and 8 are in common. Each of these numbers, 1 through 8, can only occur one time in this picture. So you can't put the 6 here and also here. I know it's in both A and B, so what I do is I put it there. And 8 is in both A and B, so it would go there. So then with set A, we need to locate this element 1, so it would have to be in set A, but it's not in B. And then down here we have 2, 4, and 7 that would be here because they're in set B, but not in set A. Okay? Now, there's a little more to do because we have to go back to the universal set. We have to take care of the numbers we haven't mentioned so far. So like we've already placed 1 and 2, we've already placed 6 and 8, we've already placed 2, 4, and 7. Okay? So all that's left are 3 and 5, and 3 and 5 are not in set A or set B. So put them somewhere around the outside of those. Okay? So this is your universal set right here. Okay? And 3 and 5 are in the universal set, but they're just not in either of those. Okay? So that's how you could create a Venn diagram if you're asked to do so or if you want to do so. Okay? Now, I believe we completed 11 and 12. I think I'll go ahead and work through number 12 since I'm not 100% sure we finished all of those. So let's go ahead and take a look at that. So we're going to try to do it from the diagram if possible, but if you prefer working with lists of numbers, you could always write them as lists of numbers. Here we're actually being asked to write. To find each set kind of means list the numbers that are in set A. Big thing there is don't forget about the 2 and the 9. They're inside the blue circle, so you need to include them. They would be included in both set B and set A. Okay, so set B would be 2, 3, 5, 6, and 9. Doesn't really matter whether you have the order correct, but if it's possible to do so, it's kind of nice. Also, make sure you didn't leave anything out by counting. Notice how there's 1, 2, 3, 4, 5 elements in set B, and there's 5 elements in set A. All right, now for the universal set, I'm going to go through and see. I'm thinking it's going to be all the numbers from 1 to 11, but I'm going to kind of just write them if I see them. So there's 1, there's 2, I see 3, 4 outside, Then I see a 5 and a 6 in set B, and then a 7 and an 8 over in set A, and then I see a 9, and then 10 and 11 are outside the circles, and that's the biggest number. So it turns out the universal set really is all the numbers from 1 to 11. Okay? When I do the intersection of A and B, I don't need to write down the list and look at the list. I could, since they're there, I could notice, oh, there's a 2 common to both, there's a 9 common to both. But if they hadn't asked me for set A and set B, I would have just looked at the diagram and said, it's going to be the set consisting of 2 and 9. All right, now we're getting into some that involve complements of A, okay, and I also need the complement of B. So let me go ahead and get those. So A's complement would be all the numbers outside of the blue circle. So that would be 3, 4, 5, 6, 10, and 11. I can look at the picture to do that, or I could look at the list of numbers below. B's complement would be the numbers outside the B circle. So that would be 1, 4, 7, 8, 10, and 11. Okay? All right, now let's go ahead and be working on these problems. So if I need the complement of A and I want to union that with B, I could try to do it from the picture. So the complement of A would be, I'm going to circle them. That would be these guys here, okay, together with these guys here. What you see in blue, that would be the complement of A outside circle A. I could just look at the list, okay. Let me get rid of that B. I don't want the B included. So these elements here and those elements, that's what I've listed there. But if I was trying to do it without the list, I could look at that. Now, when I union it with B, that means you have to either be in the complement of A, which I've circled in blue, or you need to be in set B, which I'm circling in green, which are all those elements. And union means you could be in one, the other, or both. So what I would do is I would write down all the numbers that are in the green circle together with all the numbers in the blue. Okay, so it would be 2, 3, 4, 5, 6, 9, 10, and 11. Okay, now if I already have the lists, I could just look at the complement of A, and I could look at set B, and I could compile those together. I could just get all the elements that I see in either of those and pool them all together to come up with this list. Okay, see the 2, the 3, the 4, the 5, the 6, the 9, the 10, the 11. Okay, now when I go to do intersection of those same two sets, so now I'm going to work on the intersection of those two sets. Then I'm looking at what I circled in green, which was set B, up here. I'm looking at trying to do it from the picture. What I circled in green, that's set B. What I circled in blue, that's the complement of A. If I want the intersection, they have to be in both of those sets at the same time. So that would be just set 3, 5, and 6. Okay, so that one would be just 3, 5, and 6. So if I looked at this set and I looked at this one, and I'm looking for what's in common, it's just the 3, the 5, and the 6. Another way to read that is that you're in A and not, oops, I said it backwards. You're in B, but not in A. In B, but not in A. Another way to see that. Okay? All right, now let's go over to this guy next. We want A, and we're going to union that with the complement of B. So I have to look for A, set A. I know that I'm going to have all the elements in set A, and then I'm going to pool those together with all the elements that are outside of set B. So that would be these guys together with these guys. And union means you can be in one set, the other, or both. So any number that's in either the green or the blue circles that I made should be included. So that would be 1, 2, 4, 7, 8, 9, 10, 11. Now, if they wanted the intersection of those same two sets, then it would be the green 1, 7, and 8, just the 1, 7, and 8. Okay. Now, A union B's complement, that's a fun one to do from the picture. So let me clean up my picture. So your focus, now we're focusing on this guy over here. Okay. So we don't want to be in the union of A and B. So the union of A and B would be this. So if we're not there, then that means we're 4, 10, or 11. Okay? All right. Now we've got some operations involving the difference of two sets. So A's complement would be outside set A. So here, both of those would be A's complement. You know, we've already did it earlier. If you wanted to, you could list them if you found that helpful. 3, 4, 5, 6, 10, and 11. Okay, so I've already listed those earlier. I could do that. Now I want to take away any of the elements that are in this set. Okay, any elements in this set that are in set B. So I would take away 3, 5, and 6, and what would be left would be 4, 10, and 11. Okay. So that would be my answer. I don't think I should do equals there. That would be my answer. Okay. And I can see it because if I have in green the complement of A up there, and then I want to take away any elements that are in B, then all that would be left would be 4, 10, or 11. Okay. And then the last one, A minus B in parentheses, complement of A, complement of the difference of A and B. Okay. All right, so let's take a look at that. Having trouble getting it to erase. Sometimes it just freezes a moment. Okay, so the A, take the difference of A and B. If I took that, looked at the diagram, then here's my circle that shows all the elements in set A, and I would take away elements from B. So that would be the set consisting of 1, 7, 8. And I need the complement of that. So remember, the universal set are all the numbers from 1 to 11. So that means I want all of those numbers except for 1, 7, and 8. So 2, 3, 4, 5, 6, 9, 10, and 11. That would be my answer. Okay. So I could go to the picture once I know that the difference of A and B is just these guys here, okay? Then I could say not that, okay? So then I want not that, which would be all the numbers that are not in blue, okay? So that would be those 8 numbers that are not 1, 8, or 7, okay? All right, now here we're being asked to draw a Venn diagram to represent the set. This can take a little work, like sometimes I have to do some scratch paper on it, okay? This one wouldn't be bad though. If I want the complement of the intersection of the two sets, then I just want to not be there, okay? So let me just say that, not here in the middle, okay? So that means I would be outside of that little middle area. Just not in that middle area, okay? Now, we really hadn't supposedly learned about De Morgan's law, but it turns out that these are going to wind up being the same picture. This is going to wind up having the same meaning as that, but we can actually work that out and see it, okay? So I'm going to work on that now. I'm going to do it over here. A's complement unioned with B's complement. All right, so I'm going to take A's complement first. A's complement would be outside set A. Okay, I'm going to do that. in blue. Outside set A. Right, see that? Okay, then I'm going to do B's complement in green. Outside set B. Okay, so there's that. And then I want the union of those two sets, right? The union of those two sets. So that means I want anything that has any shading whatsoever in it, okay? So if I think about that, if I look at that carefully, the only place that doesn't have any shading is right there in the middle. So you want everything shaded except right there, just not here. Actually, what we just did actually proves that these two things, since they turn out to be the same shaded region, no matter what, they're always equal to one another. And that's a proof of De Morgan's law, which we'll talk about later. Okay, let's try to figure out A's complement intersected with B. So sometimes I have to do some scratch work for that. So let's get A's complement. Okay, A's complement, that would be outside of circle A. Set B, okay, outside of circle A. All right, so that's A's complement. Now, B is this, okay? And now I want the intersection, so that's and. So that means I have to be shaded both green and blue, okay? So when I kind of figure that out, summarize that, do you see that it's going to be outside the A circle, but inside the B circle. So it's got to be just this region here. That is a complement of A intersected with B. So it's outside A, but inside B. All right, now let's try this one. All right, so here I need the complement of A intersected with the complement of B. All right, so if you knew De Morgan's law, there would be a quick way to think about that. But assuming we don't know that, we would start with that. Here's A. Oh, we got 3 sets, so I need 3 sets. I'll make it a little bigger. Okay, here's my 3 sets. Here's my A, my B, my C. Okay, so I need to be outside A. So here's outside A. Okay, need to be outside B. I'm going to do that in green. Outside B. Okay. And then C, I'll do in purple, means I have to be here. Okay, so that's in purple. All right, so what I need is I need to be outside A, not in A, not in A, not in B, but in C. Okay, so if you think about it that way, can you see that our final answer means I can't be in that circle or that circle, but I have to be in this one. Let me change color back to blue. So I have to be in C. Okay, this is set C. I have to be inside set C, but not in A or B. So I would be just that region. All right, one more problem, and then I'll do a new video for the Section 2.4 material. All right, this is going backwards. This is giving us a picture and asking us to write it in symbols. So if you notice here, what's shaded is inside A, B, and also C. So I have to be in the intersection of those 3. You could put parentheses, but you really don't have to. You could say that, or you could say that. The order you wrote them wouldn't matter, so you could just say A intersected B intersect with C, and that would be it.